Hey guys, my name is Nick. Today I'm going to give you a short intro on Bayes' theorem. Bayes' theorem is a theorem widely used in probability and statistics. It can get, like PhD students in probability will be using it, but you also just get an introduction to it if you're taking one math class your whole life with a little probability in it. So there's a wide range of use for it. And we're just going to go over an intro for it today. So what is Bayes' theorem? In mathematical terms, this would be Bayes' theorem. Probability of A given B is equal to the probability of A times the probability of B given A divided by the probability of B. So what does that mean? What can we use that for? What it means really is, say you have two events. Let's say the probability that school is canceled and the probability that it snows. And you want to figure out the probability that school will be canceled given that it snowed. All you need to know is the probability that it snows, the probability that school will be canceled, and the probability that it snows given that school will be canceled. Now, that's not a scenario where we may know all these probabilities, but the only time you'll really use it is when you do know all these probabilities. So a highly used example, one I don't think you can learn about Bayes' theorem without going over in some way, is they'll give you an example where there's some type of disease, illness, something like that, and there's a test for it. And they'll give you the probability of the disease, having the disease, the probability that you'll test positive given that you have the disease, the probability that you'll test positive given that you don't have the disease, and then they'll ask you the probability that you have the disease given that you tested positive for it. So let's do an example like that. Let's say that there's a disease called disease hypolacta, and let's say that 0.5% of the population has hypolacta, and we'll say that 99.5% of the population does not have this disease. We'll also say that if you do have hypolacta, the probability that you test positive for it is 99% chance. So only 1% of people have a false negative test. And then let's say that if you do not have this disease, that there is a 99% chance the test will be right that way as well, which means that 1% of people have a false positive test for it. Now, we can figure out what's the probability that you have this disease given that you tested positive. And if you want to write down a guess, I bet you will overestimate a little. This is one of the probabilities that intuitively it's hard for us to guess, but let's see how close you are. So I've drawn up a little diagram here that shows the probabilities. And so, Bayes' theorem, let's go back and look at it. We need the probability of A, probability of B given A, and the probability of B. But first, let's define A and B. We'll call A the event that someone has the disease, and B the event that someone tested positive. That makes this all work out for what we're looking for. So first, what's the probability of A? That's pretty easy. Straight up in the problem, it says, what's the probability that someone has the disease? It's a 0.5% chance, so 0.005. Now, what's the probability of B given A? Also, straight up says in the problem, what's the probability that you test positive given that you have the disease? That's a 0.99 chance. And then probability of B is the harder one. What's the probability that someone tests positive? Here, we're going to look at all the ways someone can test positive. You can either have the disease and test positive, or not have the disease and test positive. So there's two routes. We're going to multiply those probabilities together and add them up. The ending will look a little like this, where we have P of A times P of B given A, and at the bottom we have the probability of B, just the whole space, the whole probability someone tests negative. And the answer might surprise you. It is actually 0.332, so there's only a 33.2% chance that this person will have the disease given that they tested positive.